In the last episode, we discussed about how type of the study outcome determines statistical methods. Episode 5, we continue from that to the goal of statistical methods for each research. Recall that there are 4 types of study outcome determine various types of statistical methods. But the key to go closer to the success, one really need to be able to imagine or to understand or to touch the data that will be used for this statistical analysis. If you can generate a mock data set for your own research, that means you are closer to the success goal. Or even you read a paper, you can imagine how the data of that paper would look like. When you read the design and data collections or data management sections of it, you can understand or can do this, can design this. So this is a good practice. The first row is the variables. Y stand for to designate the primary outcome. Usually there is only one. If more than one, use this one as the primary outcome. And X, usually more than one X. So here, some X could be the covariates. Some X could be the X of interest. It depends on the research question. So the general format is like this. First row is continuous, variables, and the subsequent rows are record or the data record. We have n row of these. For example, if we have the Y like this, the first participant, identification number 1, 2, for example, the number of occasions or number of smoke per day, like 2 cigarettes per day. The second participant reported smoke 2 cigarettes. The third one 0, no smoking. The third one 2. The last one 14. Like that. How can we summarize? The last one is 6. How can we summarize this? Of course, we use the mean or the median. We really need to examine which one is the most appropriate summary of it, and how we summarize it in the very most appropriate way. So it's not just jump into the summary of mean, but need to be carefully explore the distributions of the data, which we will continue later in this next section. Now, if I change this Y to 0 and 1, coded, the number is not the quantity anymore. It's just a symbol, like 1 usually refer to yes, 0 refer to no. So this is a dichotomous outcome. Not continuous, but dichotomous. This is wrong. What we can summarize is the number and the percentages, and continue to more advanced or complex analysis later after you understand the basis of it. The summary is that appropriate to type of the outcome. So this is how you walk closer to the success goal. the next one I like to discuss with you is the common type of statistical goals for researchers. Some research have a single measurements. There is no comparisons, just describe one group. For example, the prevalence of or the incidence of whatever in these populations. So we quantify the percentage or the mean according to the type of the outcome and confidence interval of that quantity, and just that, you know. Some compare between group, but use one minus another or subtraction. So that means we quantify the difference as the magnitude of effect to answer the research question. Some compare between group using one divided by another or division. This is called ratio, like odds ratio, risk ratio or relative risk, incidence rate ratio, or hazard ratio. Some goals is not to compare, but to predict. You know, if the independent variables or the factors is like this, how the outcome would be. The diagnostic test study or the study to develop predictive models or scoring systems fall into these categories of the goals. Some studies demonstrate the correlations between the quantities, how high or low the variables correlated to each other. Some quantify the agreement, how the two go along together. The difference or can be used interchangeably or not, something like that. So be clear from the research question what is the main purpose, and that's become the statistical goals, and we will quantify accordingly for that magnitude. Recall that if we know about type of the outcome, about goal, about the study design, we have guide. So here one of the two common guide that I just demonstrate to you that how. For example, if continuous outcome is, do we aim to influence on mean or to determine an association between the factors and the outcome? That is the goal, you know. So if influence on mean, how many groups? If one groups, we have guide, we have methods. If two groups, the third question arises. Is it independent groups or dependent groups? If independent, go for the difference like this, the two difference between the two means. But if dependent is the mean of the difference, for example, both the quantity and confidence interval and test for hypothesis, there are two components for each boxes, you know. For three groups also, independent or not, and this go to different methods of analysis. But for determined association, it could be for predictions or to demonstrate the relationship between factors and outcome, you know, go into different ways, something like that. If now there are the third issues arise, you know, and I like to summarize here. The first issue is type of outcome. We know where to go. In this each type of outcome, there is a question: influence on mean or association. The first one. Is there comparison between groups? The second one. If the second one has more than one group, there are further questions about independent or dependent or not. We will talk about this later. Dependency among observations is the issues here that need different statistical methods to handle it. The last one is about non-parametric statistics. Many textbooks has emphasis a lot here, but I will not, because all these are test hypotheses and give only p-value. What we are looking for is how large is the effect. I mean, more emphasis in parameter estimation than test hypothesis. But for now, you need to understand it, because you might be asked by the reviewer of your article, Okay, so keep in mind about when we see here non-parametric statistics, I mean the above here is the parametric statistics. So there are two types of statistics. We will discuss in details later. The same, if we know that our outcome is the categorical, common question like influence on proportion or association, how many groups, if more than two, dependent or not, all of these kind of things. So it's common. Everything, if you understand this concept like this, even you don't know, you have a good question to search further or to ask for help, to consult those who are knowing in the right way. Now, the one that I like to introduce here is that usually statistics assume the outcome is independent. That means how large or the variability of it is independent on the other observations. If this is not the case, that means there is an dependency of the outcome across the observations, or dependency among observations. One outcome depends on other record, other observations or other record. That means there is dependency among observations. It's required special statistical methods to handle it. Okay, the example of dependency or correlated data, like if the study design is before or after or pre-test, post-test designs, that means the level of what you measure is measured in the same observations. One is for before, another is for after. So it's independent. So it's not independent. Depend on what participant, for example. Paired organs like ears, eyes, arms, within the same, depend on who, whose eyes, whose ears, Longitudinal data or repeated measurements, measure several times in the same participants or the same observation unit. Cluster data, even they're different observations, but they're clustered on something, for example, curing, outcome is cure or not cure, curing of asthma depend on medical doctor, depend on the physicians. For example, who treated, not only the different participants. That's the cluster, or some family member, the same family correlated in in that outcome, for example. So many observation units within a cluster is another type of dependency among observations as well. Now, choices of approach could be ignored if it is, the first one is not advisable. Ignore it means just go ahead with assuming independence between among observations that is wrong. It will be said only they are not independent, but who knows? We need to handle it. Some approach is simplify it, mean use a summary of many measurements, but summarize to be one and analyze as if it is independent. This is also not advisable because it's not efficient. It means we reduce or destroy a lot of data. So we need to handle it by special statistical methods. I mean, it's quite advanced, but we cannot avoid it, So if you avoid to confront with a sophisticated thing, you need to know you need this and need a colleagues who know this to help. We work as a team. So if there is dependency of the study outcome, I emphasize the study outcome, not the independent variable, the dependent variables only. We need the methods, the methods that the same things here, but have methods to handle it. Sometimes we use the mixed model, linear mixed model, logistic mixed model, Poisson mixed model, and could be multi-level or generalized estimating equation or GEE, to get the magnitude of effect. That's mean what? That's mean whatever you use, still go for how large is the effect with the confidence interval and p-value, if you like. Still, not just about the name of the methods and end up with something that is not this. So my last slide in this episode is always report the magnitude of effect. Quantify it with its uncertainty or the possibility or confidence interval. Sometimes we report absolute effect like mean or mean difference, proportion or proportion difference or risk difference, or median survival times, absolute. Sometimes we report relative effect like relative risk, rate ratio, hazard ratio, odds ratio. Because absolute, like I would write something here just to allow you to understand clearer. For example, if you have I check about the rest or the risk difference. If one group is about 80% cure, for example, versus another group is 40% cure, the risk difference would be 40%, right? 80 minus to 40. But the relative risk would be 80 divided by 42. You see, this is absolute, this is relative. Now take another example, like if 4% was 2%, this become 2% difference, the absolute. But for the relative, it will be 4% divided by 2%, remain 2. You see, this is how different it is. This is stable, but this gives you another view of the magnitude of effect. So be careful about what should be analyzed or goal of the inference. Some magnitude of effect, like correlation coefficients, which is determined by R, how correlated it is from 0 to 1. 0 means no correlation, 1 means perfect correlations. Interclass correlation is to see the quantities go along with together, using in some research to demonstrate about the reliability, for example. Some could be kappa to get the agreement. Some could be diagnostic performance, like sensitivity, analysis, sensitivity, specificity, predictive value, whatever. There's a lot. So most common statistical methods is around this to get the magnitude to support the conclusions. So try to understand about this way of approach. Then you will see statistics is really tools for wisdom. We get the magnitude. We know how it's interpreted, and we can make a good and understandable practical conclusions for our research. See you the next episode.